Hi, today we're going to look at dilations. This is our last transformation. This is the one transformation that we have that is not a rigid transformation, that it actually is going to change the size, and so it doesn't stay the same shape always. All right, so if you look at this, a dilation is kind of like when your eyes dilate, they get bigger, or you get something that's smaller. It's like that. Okay, so if you look at this, the information that you would need to do a dilation is you need to know what you're dilating it from. From what point are you stretching it out or shrinking it? And so right here I'm going to dilate from point C, and you can look, here is my pre-image. And if I were going to, I don't know, double it, then what I'm doing is I'm measuring how far is it from my point to a certain spot on my shape. And then I would lengthen that and go double, or whatever scale factor it's asking me to do. And I just do that with every point. So I measure to Q, and I go that distance again. Measure to R, go that distance again. Okay, so let's try some. Our notation, it's a D for dilation, and there's two things that you need to know. You need to know what the scale factor is, how big or small do you want to make it, and then C in this example is the center of that dilation. So let's practice writing our notation here. On this first example, it's a dilation. So I write dilation of. Now the first thing is the scale factor, and they're going to give you a couple sides so you can compare them. If you look at these corresponding sides, this is the pre-image, it's a 2. This is the image, it's a 4. What did I just do to that? Well, I just doubled it, so it's a scale factor of 2. So I'd put the 2 there, and then the center of it is where is it stretching from, and that's this point right here. You can see this point did not change. A and A prime are the same, and it's stretching out from that point. You can see it was to there, now it's along there. So then I'm going to put A is my center of dilation, and then I can put of the quadrilaterals, so I'm just going to say A, B, C, D. Okay, why don't you take a minute and see if you can't do the notation for this second one. Go ahead and pause the video and do your notation. Okay, I probably should have talked about it a little bit before. Did you catch that? This one is actually a shrink. The pre-image, the EFGH is the bigger one, and then the E prime, F prime, G prime, H prime, those are smaller. That figure is smaller, so it shrank. It was an 8, now it's a 2. That's a scale factor of 1/4. It's 1/4 as big as it used to be, and it's all shrinking down towards the middle of that point C. This is your notation. All right, so let's look at this one and see. A big thing is to notice, like this is a multiple choice, pay attention to whether it's an enlargement or a reduction. So looking at this, the black figure is the XRT, right here, XRT. And then here's our X prime, R prime, T prime. So it looks like it's getting bigger. So I know it's one of these options. Now, how much bigger is it getting? All right, well, this is a 4. And then this measurement is an 8. Now they're trying to be sneaky on you here, because if you look at what the blue triangle actually is, the entire side is 12. That's a little bit sneaky. So it went from a 4 to a 12. How much bigger did it get? 3 units. Okay, so be careful when they label that 8 there, that's not really the measurement you're wanting. Okay, now let's say that you're going to do your own dilation. It says, and if we're going to try one here on the coordinate plane, and you can find the coordinates of the dilated image by simply multiplying those coordinates by whatever your scale factor is. So that makes it really easy. If you have some ordered pair and you're like making your figure double in size, well then you just take your coordinates and you double them. That's pretty easy to do. So let's try this PZG triangle here. I'm going to start off with P, and I'm going to write the original coordinates. P is going left 2, up 1. So that's a -2, 1. And I'm going to go ahead and just do all the coordinates and then I'll come back. Z, this one is over 2, down 1. So that's a 2, negative 1. And then we have G. G is over 0, down 3. Now they're asking me, says, what are the coordinates of the vertices of, look at this right here. Now this is their notation. Notice they skipped that center of dilation. Ultimately, when we're on the coordinate plane, we're going to probably dilate from the center, from the origin, unless you're maybe dilating from one of the vertices of your triangle, but we're going to default to dilating from the origin. So that's why they didn't put the center of dilation. All it really tells me is I'm going to double all those coordinates. So I'm going to put a negative 2, and I have to double it. So it's a negative 4. 1 turns into 2. 2 turns into 4. Negative 1 turns into negative 2. 0 times 2 is just 0, and 3 times 2 is 6. And then I come back and I can plot those points over 0 up 6. Oh, did you catch this was supposed to be a negative 3? I missed that. That's a negative 6. Okay. Over 0, down 6. Got it. Over 2 is now over 4. I'm doing my Z, down 2. There's my new point Z. And the P is now negative 4 up 2. All right. And then this is our new triangle that has been dilated and been stretched. And if you want to label that, this would be a P prime, and this would be a Z prime, and this would be a G prime. All right, let's look at these examples. The blue figure is a dilation image of the black figure. That's consistent as always. Our black figure is the pre-image, blue is the image. The labeled point is the center of dilation. Okay, and so by that, it's the O. Basically, the labeled point. It's O. Okay, and here it's O, and it's always going to be our origin. Tell whether the dilation is an enlargement or a reduction, then find the scale factor of the dilation. All right, to find the scale factor, you look at what your resulting image measurement is, and you put it over your pre-image measurement. So usually what I'll do is I'll try to find some corresponding sides and compare their lengths. Okay, let's look at these squares on this first example. Remember, you start with the black triangle, that's your pre-image. You go to the blue image, you can see that this is a reduction. This is getting smaller. And then to see how much smaller, I'm going to find some corresponding sides. And really, it's a square, so it doesn't really matter which ones. But I know that my image here is 2 units on each side, whereas the pre-image was 4 units. So I put the image over the pre-image. So that's 2 over 4, which of course would reduce, so I'd say it has a scale factor of 1/2. Okay, let's try again. On the next picture, starting from the black figure going to the blue, it looks like it's getting bigger. So this one is an enlargement. To find our scale factor, find a couple sides that match. I usually try to find like directly horizontal or vertical ones because that makes it easier. This side here is a 2, whereas over here it's a 4. Now remember that you're going to put the image, which is blue, over the pre-image, which is black, so that's going to be 4 over 2. And that again would reduce, so we're going to say that it has a scale factor of 2. All right, I'm going to give you a minute to see if you can do this last one, going from the black figure to the blue figure, decide if it's a reduction or enlargement, and then by how much. All right, I'm going to say that this isn't an enlargement. It got bigger as it turned into the blue figure. And then to compare corresponding sides, I'd probably put this 2 and compare it to this 3. All right, image on top of pre-image. The end result over the original. End result over the original. 3 over 2. And if nothing else, if you get it backwards, check and make sure that it makes sense. If it's going to be an enlargement, then the scale factor is going to be bigger than 1. But if it's a reduction, that scale factor is less than 1. All right, let's try one that's a little trickier. It says here, find the images of the vertices of triangle PQR for each dilation. Graph the image. Okay. We're going to find this P, Q, and R that we have, and we are supposed to be, looks like, reducing it by a scale factor of 2/3. Now, sometimes you can just look at the picture and figure that out, and sometimes you have to do some math. All right, well, if I look at this, and I'm going to do it through the origin because that's our default, goes through the origin. Look at how far out here to the pre-image we've got. We're 3 units out there, and we're going to shrink it. It's going to be 2/3 of that. Well, that's not rocket science. If that's 3 units, I want to go 2 units. That's 2/3, 2 out of the 3. So right there needs to be my new point. I'm going to go 2 units. And actually, can't you do that this way also? To get to this point, it was 3 units, but I only want to go 2/3 of that, so this is going to be my new point. Okay, so that's what I'm going to do there. This one's a little trickier because it's not right on the axis. Let me go ahead and plot my new points. So I know that's going to be P prime, that's going to be Q prime. And now I'm going to show you the other way to do it. If you can't just eyeball it and figure it out, then let's work with the coordinates. Point R is over 1, down 3. Now what I have to do to find R prime is I have to take that coordinate and I have to multiply it by my scale factor. All right, so 1 times 2/3 is just going to be a 2/3. So we will have to just estimate some fractions here. But on my second one, I can write that over 1. The 3's cancel, and I'm left at a -2. And so that's where R prime is, and I'm just going to estimate over 2/3 down 2. And so it's going to fall about right here-ish. And it does not necessarily have to fall on that triangle. It looks like it kind of does, but it does not. That's a coincidence, really. And then draw your new figure, and you've got it. There's your dilated triangle. All right, fine. This one is for you. Same idea. If you can just figure this out on your own, that's great. If you want to just use the coordinates, because to be honest, I'm looking at this and saying, okay, I'm trying to double this, which means it's going to get a lot bigger, which I think is going to be way off of this graph. So maybe instead of graphing, it does say graph it. What if we just went and found all the coordinates? So you find the coordinates for Q, the coordinates for P, the coordinates for R, and then dilate them to find new coordinates. All right, so go ahead and pause the video. You go do this work. Come back when you're done. All right, here's what I have. Now, I went ahead and graphed it and got an idea of what it would look like, but because I wanted you to see this, and I wanted to go back and revisit that idea of wherever your center of dilation is. Remember the idea that in this case I'm doubling it. So if I draw it to Q, all I do is I double that and I land at Q prime. If I'm drawn to P, I just double it and I land at P prime. Draw to R, double it, and it lands on R prime. So I could use a compass would work awesome for this, because I could just take my compass and measure to Q, and then from Q measure off again. All right, draw this line, measure to P, measured off again, and I'd have my P prime. So it'd be really easy, and you'll do that on your homework, is construct a few of those. Okay, here's our last thing, and this is just kind of working with the ordered pair again. So this is actually probably easier than what our previous one was, but because I'm just doing 1 point. I've got this point L, and I want to dilate that point 5 times bigger. All right, so what's L prime going to be? Well, I just got to take those times 5. So it's a -15, 0. that's where it would land. Point A, looks like I'm trying to dilate it 1.5. So my A prime, I would take -6 times 1.5. Ends up being -9. Take 2 times 1.5. Ends up being 3. And so maybe you're just doing 1 point, maybe you're doing a whole figure. The idea is the same. Dilations hopefully are going to be easier for us than some of the other ones we've had to do. All right, good luck.